Have you ever left a partially deflated basketball in the trunk of your car, then in the afternoon took the basketball out of the trunk to find that it had almost gained its normal volume? Or have you ever placed an inflated balloon in a refrigerator to later find it deflated? Well, gases respond majorly to three factors, which are temperature, pressure, and volume. Our problem is, what are the relations between temperature, pressure, and volume related, and how can we see them or prove them? We researched information about volume, pressure, and temperature because we knew that we were going to work with this, and we needed more information. Volume is the three-dimensional space that a substance occupies or is surrounded by a surface. The standard unit of volume is m cubed. Common units to measure volume could be liters, cubic meters, millimeters, milliliters, and more. Gases are commonly sold in units of volume. Temperature is defined as one of matter's properties. It reflects the amount of energy of motion within particles. It is compared to the measure of how cold or how hot a substance or object is. The unit the unit for temperature is Kelvin, but Celsius and Fahrenheit are commonly used. Thermometers are used to measure temperature. Pressure is defined as a measure of force that is applied over a unit of area. You can get pressure by the equation of pressure equals of P equals F over A, where P is pressure, F is force, and A is area. Volume, pressure, and temperature are related to gas laws. They are used to measure parameters of a gas mass. They can also tell the properties of gases. And there are different gas laws, such as Boyle's law, Charles' law, and Guy-Lussac's law, which are named after their discoverers.
Pull the syringe plunger backwards to introduce air to its total capacity. Place that dynamometer and pull downwards slowly on the syringe plunger. Take note of the values in the dynamometer and the volume in the syringe. Then stop pulling in the dynamometer, found pressing the cylinder. Make an X, this X versus Y graph to establish the relationship between the variables and determine the type of tendency shown on your graph. Introduce a specific amount of volume of air into your syringe. Seal the extreme of the syringe with needle opening and introduce it into a big with hot water. Repeat the previous step with the other syringe in a beaker with ice cold water and observe what happened between the volume and the temperature in both trails and explain why. Make an X versus Y graph to establish the relationship between the variables and determine the type of tendency shown in your graph. Place one of the small beakers, one in ice cold water and the other in hot water. Follow the instruction on how to use the tablet to obtain your data. Make an X versus Y graph to establish the relationship between the variables. This is our hypothesis. These are the materials we use during this experiment. This is a table that represents our results. Here you can see the variables analyzed, the graph obtained, the tendency of slope, and the Gauss law that best describes gas behavior.
We got to a conclusion that temperature and pressure are really related to each other. They all depend to each other. If pressure increases, the temperature will also increase. If pressure decreases, temperature will also decrease. When the temperature is high, the molecules move faster and the force of the pressure increase. The only difference about the pressure and the temperature is that the pressure is proportional to the genetic function to the genetic energy per unit and temperature per particle. That makes a difference between each other, but they work together. With all of this, we conclude that it is true. The pressure and temperature depend on each other.